Hi, I'm Giri. Welcome to Auckland AWS meetup for September. So today we are co-hosting this meetup with AI Camp. And so I'd like to thank Bill for reaching out to us and helping us organize this event. Thank you. Before I hand over to our guest today, so I got an update about our next meetup for the Auckland, that is. So we have our usual venue booked, which is Grid Auckland for 1st of October. But whether we'll be able to have it there or whether it will still be an online one would largely depend on the COVID situation, and we will update you towards closer to the day. So please watch this space. We'll put an update on the meetup page. So that's about it, the meetup updates. And so today we have our guest speaker, who is Gus, who is a AWS machine learning hero, and then he has quite extensive experience on deep learning and building and architecting large-scale end-to-end machine learning pipelines. So we are quite excited to have him on board with us. So without further ado, then to Gus, over to you.
Thanks, Katika. So good morning, afternoon, and night, everyone, depending on wherever you are. So let me just start with sharing my screen. So today, I'm going to talk about the technology that I built. It's a technology that solved my watch problem. It's a what should I wear today with AI? And the technology I'm using is an Amazon Sagemaker and AWS DeepLens. And as Katika mentioned, my full name is Agustinus Nalwan, and I'm the head of AI and machine learning at castles.com. And I'm also an AWS machine learning hero. And just before I start, I'd just like to tell you a little bit about myself. I work for a company called castles.com.au. So for people who audience in Australia, so probably most of you probably know. Yeah. So we own a car portal which facilitates car buying and selling. And we have both private and dealer. So think of it like an eBay, but for car. People come to buy and sell car through our portal. Yeah? And at any given time, we have about 230,000 cars. That's before COVID. But after COVID, a lot of people buying a lot of cars because they do not want to take public transport. So this stock level actually drops, which is good for us actually. And at any given day, we're having 5,000 new cars. And apart from cars, we also have a bike, boats, trucks, caravan, and anything with wheels on it. Yeah? And we also have a portal in many countries, like in Chile, Argentina, Brazil, Mexico, South Korea. So yeah, so basically we're an international company. So my passion since 5 years ago, it's all about AI. Yeah, prior to that, I wasn't in the AI industry. Yeah, but like all of you know, in IT you have to keep changing and you have to actually keep trying the new things. So 5 years ago, I fell in love with AI because I can actually use AI to actually build so much more. I can actually solve more problems, yeah, with less resources. And luckily, I work for a company where I can actually apply my passion, yeah, in building AI technology and solving problems. Yeah. So me and my team members at Castles, we built lots of AI technology, and one that I'd like to mention in particular that we built about 4 years ago, it's called Cyclops. It's a car recognition. So it's an AI model, computer vision model, which identifies the car by photo. It can tell you what is the make, model, body, year, all the way to the trim level of your car, just from one single photo. This technology is driving all our mobile apps. So when you sell car through us, you do not need to tell us what car it is. We already know what the car is better than you do. And the second technology I'd like to mention at Castles, it's called Stick. It's a ratio blurring technology. And what it does is basically for all of the advertisement that was uploaded by seller, yeah, we look at where the ratio number in the photo and we blur them. Yeah. And this is to protect your privacy, because a lot of scammer and criminal actually come to sites like car sales, eBay, Gumtree. They all trying to steal the ratio plate number photo of a car that looks like similar to what they have. And then they print this photo, stick it into the retro plate, they drive to a petrol station, run away without paying, and commit all kinds of criminal activity. So this is very serious. So we use this technology to actually protect our sellers' privacy. And as an AWS machine learning hero and evangelist, yeah, So I also have a passion in presenting in the communities. I present in meetup like this, in conference and in summit. Yeah. So I'd like to spread my experience and knowledge to as many people as possible. So for everybody to actually embrace AI and to grow our AI ecosystem, especially in Australia. Yeah. And the reason is because I still see that a lot of people have perception that if you want to jump into AI industry, you have to be really, really good at math, or you have to have a PhD degree. Yeah. And that's not true. I want to change this people's perception, because that's probably true 5-6 years ago, yeah, when I started the AI journey at Castles. But now, as a year goes by, a lot of higher level tools is super easy to use, yeah? Like Amazon Sagemaker, for example. These tools are super easy for you to use as long as you know how to prepare the data. Yeah, you prepare the balance balanced data sets. You know how to evaluate the model. You do not need to have a very, very deep understanding on how this model actually works behind the scene. Yeah, it's the job of those researchers who actually build this framework and tools. Yeah. So yeah, so I want people to actually understand, realize that there are these tools available for you. So don't be scared, jump in, and then we can actually do AI together. So we grow the AI ecosystem together. Yeah. So now back to the main topic. Yeah. Solving my wife's problem. What should I wear today with AI? Yeah. So you probably question me, why do I build this technology? Yeah. Where is this idea coming from? Yeah. So it's actually coming from Yumi. Yumi is my wife's name. Yeah. And nearly every morning, yeah, she stared on her wardrobe and asked me this very difficult question: what should I wear today? Yeah. And this is practically what my face looks like when trying to answer that question. Because first of all, I'm really bad with fashion. Yeah. I do not know what looks good and what doesn't unless she actually put it on, right? I cannot really visualize it. Oh, if she's wearing that clothes, does it look good? I cannot tell, right? So, and second problem, I have a very bad short-term memory. I couldn't even remember what she wore 3 days ago, 5 days ago, last week, to be able to give a more diverse recommendation, right? So instead, I know that I have the weakness in this space. So why not I use what I'm good at, which is building an AI technology, right? To actually solve this problem for her so she can actually help herself. Right? So this is where the idea comes from. So why not if I build this AI technology that can actually recommend her clothes? And even better, if this AI knows what is the weather today, if it is sunny, yeah, it can recommend a suitable clothing, like a skirt, like this one, right? And if it is rainy, yeah, it knows to actually to recommend a hoodie, yeah. So it's a weather contextual, yeah. So I started to brainstorming with myself, yeah. What do I need? How do I build this? Like, first of all, you need to know what information that you actually require to be able to recommend an outfit to wear, yeah. So, like I mentioned earlier, yeah. So the first information will be, what do you wear recently? This is a very critical information, right? Because you do not want to wear the same clothes every day, yeah. You want to show a bit of diversity, yeah, in your fashion, right? And you also need to know as well which clothes actually you look good in it, right? So you need to, some sort of like a fashion diary, yeah. So I call it a fashion diary, a diary that actually show you every day in the past what clothes that you wear, yeah, with a photo. Yeah? So like that, see, you can see that on the 18 wearing the black skirt, and on the 19 wearing the colorful one. Yeah? And the second piece of information that's equally important is what outfit do you currently own, right? If you want to recommend a clothes, of course you need to know what items are there to recommend, yeah? What clothes in your wardrobe, right? So this is also very critical. So we need to build a system called clothes catalog, yeah? Which store every single unique clothes that she owns, yeah? Finally, once you have these two components, the fashion diary and the clothes catalog, then you can build a recommendation system. Yeah, using these two information, then you can recommend what clothes to wear today. Yeah, so this is the high level mindset I have. Yeah, so as an experienced software developer, I always know that you have to scope your MVP. Yeah, you cannot just aim for the big bang and then try to get it all done, and at the end you will release this 10 years ago. 10 years later, right? So the MVP, very clear. First is to build the fashion diary. Yeah. Second, to build a clothes catalog, and the third, then we can build a recommendation system. Yeah. And so far, I've completed the module 1 and 2, the fashion diary and clothes catalog. Yeah. But today, due to the time constraint, I'm just going to talk about the first component, yeah, the fashion diary. If you are curious to know about the second component, at the end of the talk later, I already provided, I will provide you a link to my blog. You can read about it, about the second modules. Yeah. Or you can ask me a question after the talk. Yeah, there is a quick Q&A session after this. So, how do you really build a clothes catalog? Yeah. So how does this thing really work? Yeah. Well, the easy way is I can just rock up to Yumi's wardrobe, yeah, and just pick up every single clothes, put it on the bed, and take a photo of every one of them. Right? That's the easiest way. However, you think it's easy, but that's actually a lot of work. Yeah. What if one day she go out and do a shopping and then buy more clothes, right? There'll be more and more clothes added, and I have to do this job again and again, yeah, taking more and more photo of this new clothes, right? So this does not scale, yeah. So obviously it's not a good solution. You need a more scalable solution that works automatically, yeah. So what's the solution? Well, like I said, automated system, yeah. What if I have a camera, yeah, I install somewhere in the house, yeah, pointing hypothetically towards my front door, right? And whenever Yumi walk past, yeah, it snap a photo of her, yeah, and automatically save the photo into the clothes catalog. And the second day, when she wear different clothes, it will take another snap, yeah, and so on and so forth. And same to the third day as well, yeah, take another photo. So here you go, you have a set of photo there, yeah, and as the day goes by, now we have a photo of her every single day wearing all different kind of outfit. Yeah? This is exactly our fashion diary, right? Yeah. So now we have the photo per day, yeah, of her outfit. And then once this we have this information, all we simply need to do just need to pass in every single clothing photo into a module called clothes identification to actually check, is this clothes the same as the one currently in database? Is this the same as the one that you wear 3 days ago, right? So basically tagging them with a unique ID. Yeah, this is the same as that one. This is the same as the other one, right? And this is basically what your clothes catalog is. Yeah, it stores all the unique clothes only. Yeah, while the fashion diary store all of the clothes that she wear, regardless unique or not, by day. Yeah. So how do you build a fashion diary? Yeah, obviously you need a camera. Yeah, and then the camera need to be able to spot the Yumi. Yeah, if it is present, you need to be able to snap a photo of it. Yeah, but however, camera is a dumb hardware. Yeah, you need an AI system to be able to know that there is something object of interest in front of it. In this case, it's a person, right? So you need to connect the camera with the AI system. Yeah, and AI system normally require hardware, and most of the time it's GPU because we're dealing with the computer vision. Yeah. And most of the time, you also can just use computer, right, that has GPU in it, but it's awfully excessive. Yeah, it's too bulky and expensive. Yeah, so luckily, yeah, I found this AWS DeepLens. Yeah, it has everything that we need. Yeah, it has a camera with 4 megapixels and 1080p, and it is GPU enabled, and it has a price tag of $250 US. See, that's awesome. That's a way lot cheaper than GPU plus computer combined. Yeah. And the is only 11 by 6 centimeter. Yeah, it's so tiny. Yeah. So this is the perfect device for us. So now the question is, where am I going to put this DeepLens? Yeah. So I found this perfect spot. Yeah, it's actually in the cupboard, just facing towards the front door. Yeah. And this is actually the photo of my living room, as you can visualize. Yeah, that DeepLens on the bottom right corner there. Yeah. So why this is the good spot? First of all, it's because it's contextually suitable. Yeah. Remember that I only want to take a photo of her when she's going out of the house, because if she's just walking past around the house, I do not want to take a photo because most of the time she's just gonna wear PJs, right? And the aim of this whole solution is to be able to provide recommendation for her, for a clothes for her to go out, right? So I want to take a meaningful clothes, the clothes that she wear to go out, and you cannot go out without passing through that front door, right? Yeah. Second of all, well, there is a slight of a catch. What if she go out to throw rubbish? Yeah, you probably wonder. You do not want to take a photo of that as well, right? Because it's going to be also wearing PJ. I will not reveal the solution now. I have a solution for this, but nearly towards the end of the talk. So just put that thought for later. Yeah. And the second reason why this place is suitable is because it's safer. Yeah. Initially, I thought to put this camera in her wardrobe, yeah, pointing at the front of her wardrobe. Yeah. So that seems like the perfect place because you're gonna wear the clothes and try it on right there, right? But then you think about it, there's a danger here because our wardrobe is right next to the bathroom. Yeah. So we can all going in and out without clothing, right? And then if this photo is somehow taken and we're gonna send this photo to the cloud anyway, right? So which is bad. So if somehow it's exposed, and I'll be in a deep trouble. So definitely this is not a good place for it. So safer place just to put it in the living room, yeah, pointing towards the front door. So now we jumping into a little bit into technical, yeah. So I want to talk about the technology stack inside the DeepLens, yeah. So inside that small hardware DeepLens, yeah, there is this a module called AWS Lambda, yeah. Basically, you can write any code, yeah, and you can deploy it there, yeah. This code basically is doing all of the business logic, yeah, inside your AWS DeepLens. This AWS Lambda normally is connected to a model and also to a camera, yeah. In this case, it's connected to our human detection AI model that you deploy as well inside the DeepLens, and it's connected to the camera. The camera is part of the DeepLens, yeah. So basically, at any time, at every second, the camera send like a 10 or 20 images into your AWS Lambda, yeah. And then your Lambda can then process the images that was sent, yeah, and you can do whatever you want with it. In my case, I actually pass this into my human detection AI model, yeah. So the job of this model is to find, is there a human there? If there is a human, it will actually give me the bounding box where the human is, yeah. And I use the bounding box to crop the image and send that human photo through MQTT protocol back into the AWS cloud, yeah, where I have another Lambda ready to receive this cropped image, yeah, and send this image into Amazon Recognition to do a facial recognition. And the reason is I want to know who this person is, yeah. And if it is Yumi, yeah, so I actually train Amazon Recognition to recognize the face of people in my house, yeah. If it is Yumi, then it will store, the Lambda will store the entry into Amazon RDS and S3 bucket, yeah. So that's actually, you can see this, that the RDS and S3 bucket is actually my fashion diary, yeah, in technical terms, yeah. So now, how do you really deploy this model and how do you build and deploy model into AWS DeepLens, yeah? So I'm going to show you how. It's actually super easy, yeah. If you go to the DeepLens console in AWS website, yeah, the first thing that they will show you is actually a template of project, what model that actually you want to build, yeah. And if your model happen to be one of the model that you want to build happen to be one of the model provided here, then it's super easy. You just select one of them. In this case, my model is the object detection, yeah. It's already provided. I can just select that. It already detects 20 popular objects, including human body, yeah. So select it and then press next, and here you go. And then the whole thing's got deployed automatically into your device. And once the system is up and running, yeah, it's very cool. In AWS DeepLens console, you can actually see the IP address of your DeepLens hardware. Yeah? You put this IP address into your web browser, yeah? Then you can see what the DeepLens sees. Yeah? This is very handy for debugging. Yeah? And you can also drop in any annotation like triangle, circle, whatever text on top of it. So you can see, you can actually debug your algorithm better. Yeah? In this case, actually, I actually draw the bounding box, the blue bounding box of where the detected human, yeah, so I can see whether the model is functioning well. Yeah? As you can see, it works quite well. It detects Yumi's body there. Yeah? So, however, after playing around with it for a few minutes, I noticed more problems starting to happen. Right, I'm seeing photos like this, yeah, being captured. So I call it an unwanted detection because first of all, the face is not really visible. Yeah, and why I do not want a photo with face not visible, yeah. If you remember, if you go back to the architecture diagram slightly, yeah, you remember I mentioned earlier that I only want to record the photo in the fashion diary if it is Yumi's face. Yeah, otherwise I do not really want to record this. So if there is no face in the photo, there is no point of sending this to the cloud. Yeah, because your facial recognition will fail anyway, right? There's no face there. So then to save the bandwidth, I have to actually do an early detection. So on the device, I need to know whether is there a face or not. If there is a no face, no need to send this image all the way to the cloud. Yeah. So what it means is then I have to change this model from a human detection into human and face detection AI model. Yeah. So it's just a bit of quick overview. So given an image, we want to detect if there is a human and face in the photo. Yeah, you see the orange bounding box is new bounding box that we want to detect. Yeah? And well, the built-in object detection in AWS DeepLens does not give you the face detection. It only detects 20 objects, including human body, but not face. Yeah? So you have to build yourself. However, that's not the end of the world, because you can just use Amazon Sagemaker to build your own custom object detection that later you can deploy. Yeah? In order to build the custom object detection, of course, you need the training sets. Yeah? You need thousands of images of labeled body and face like this. Yeah? And it is not to get the labeled images of human body. Yeah. So what I did instead, to avoiding the dreadful labeling task, yeah, I do not want to label this every single photo, like 5,000 of them manually, right? I think it's more, it's up to 10,000. I've forgotten the actual number, but definitely above 1,000. Yeah. So I actually use the Pascal datasets. It's an open source datasets with already a bounding box labeled every single human body. Yeah. However, there is no face label there. That's problem. I do not want to spend even half of my time to actually label the face in the photo, right? So I did cheat quite a bit. So instead, I actually pass all of these images to Amazon recognition. Again, it's Amazon recognition, another have a subsurface that actually can do out of the box object detection. And luckily, one of the objects that it can recognize is a human face. Yeah. So then I just call the Amazon recognition, pass in all of these thousands of photos, and give me the face bounding box, and then I put that, I use it as a label to my data sets. I merge them together, I end up with a full data sets like this. Yeah. So here you go. I managed to avoid the annoying and costly labeling job. Yeah. Okay, so the data set is there. Yeah. Now all I need to do simply just to build a model. Yeah. Again, it's super easy in Amazon SageMaker console. You don't need to even write any single piece of code. Yeah. This is the new features that they deployed, I think, about last year. It's very, very awesome. You just go to the section that I want to create a training job. Yeah. Press the button, and then you choose what algorithm do you want. Yeah. In here, I choose the Amazon SageMaker built-in algorithm. Yeah. Choose the algorithm type is object detection, and specify where the training data is in the S3 bucket, and then hit the training button, and that's it, done. 3 hours later, I got the model built. Yeah. And the next thing I need to do with the model is just to import it into my AWS DeepLens. Again, it's super simple. You just go to the DeepLens console, right? You choose that I want to import the model from SageMaker, yeah? And then I put in the job ID, the training job ID in SageMaker, yeah? And that's it. The model is done. It's ready for you to be deployed, yeah? Just press the deploy to device button, and that's it. Your model is up and running now, yeah? in the device, DeepLens. Here it is. Now you can see the model now, not just bounding boxing the human body, but also the face as well. Yeah. So, okay, so all is good. Yeah. However, yeah, well, as usual, more and more problems comes later, as in any software development, right? So I'm still seeing a problem that I need to resolve. Yeah. This is another unwanted detection. So Yumi is basically just walking past in front of the camera without intending to actually go out of the door, right? So I want to be able to exclude these images. Yeah? And the second problem is I'm seeing like hundreds of images of my mother-in-law, yeah, being recorded in my S3 bucket. Yeah? And hitting the facial recognition, even though the system knows that this is not her, but this is quite costly because it's hitting my facial recognition, yeah, unnecessarily. So, and the reason why my mother-in-law is there is because she's actually very active in the kitchen. Yeah? She's actually making dumpling very often. Yeah, and that's her making dumpling there. Her dumpling is like the best dumpling in the whole world. I admit it. And because her face and body are present, yeah, the system will capture it and send it to the cloud, right? So I need to be able to get rid of this. Yeah, this is bad. So I call this a mother-in-law avoidance strategy because she's the one who contributing the most of the problem. Luckily, the solution is actually quite simple. Yeah, it's not complex at all. All just I need to do just simply need to set up the detection zone. I call it detection zone. Yeah, that red box there. Yeah, if the bounding box is not fully inside this detection zone, then I do not need to send it to the cloud. Yeah, that's how easy it is. Then you can see that blue box is totally inside the red box. Then it will be sent. But the box that is outside, yeah, like if it's in the kitchen, yeah, it's totally outside the box, red box. It will not be sent. Yeah. Same with the passerby as well. The passerby is normally very close to the camera, and the bounding box will be partially outside the red zone. Yeah. So here you go. Two problems are solved. Yeah. First of all, I get rid of my mother-in-law. Well, it's not really physically, but digitally, just a clarification. And then I got rid of the passerby as well. Yeah. So problem solved. So now you will see that the first component, the fashion diary, is all done. Yeah. So the next component that I need to work on is actually the cloth identification. But like I mentioned, this is not the topic of this talk. A story for another day to tell. If you're curious, ask me later or follow my blog. Yeah. So what I end up using the fashion diary for, yeah, to help her problem before I build the whole complete solution. Yeah, I actually built mobile apps. Yeah, it's a mobile app that actually let her browse through all of the clothes that she wear in the past few days, months, and yeah, well, hopefully years. Yeah, and this mobile app is actually called my AWS Lambda, which actually tap into the fashion diary. Yeah, so the Lambda serves as a public API to serve all of this entry from fashion diary. And then I also add another features here, sorry, that for every entry, I actually call the weather bureau to get what is the weather condition and temperature on that day, and store it together in the fashion diary. So she can actually see it on the calendar on the fashion diary app, what's the weather on that day, to be able for her to actually contextualize, oh, that was sunny day and I wear that. And this actually looks quite nice as well. Yeah? So it's a lot of information for her to decide what clothes to wear now. Yeah? So now, if you remember, I mentioned earlier that there is this problem that I promised you that I reveal how I solve it. How do I know if she went out of the house to throw rubbish or anything else that actually not really meaningful, right? So I want the system not to record this entry, yeah. So it will not show in the calendar as well, in the fashion diary as well, right? So actually, the solution is actually quite simple, yeah. If you have a GPS tracking GPS location tracking on the mobile apps, yeah, you will know whether she's out away from the house, far away, or just like within the house, within the vicinity of the house. But the problem with this is it's actually there is a privacy concern, right? I do not want to track her location and knowing where she is at any given time. That's not really good, right? It sends the wrong message. So instead, I did an alternative approach. What I've done instead, yeah, is I use the accelerometer of the mobile phone. Yeah, so my app detects her movement speed. Yeah, and based on that, I can now determine whether is she actually going out for meaningful purpose or not. Because if she need to go out for meaningful purpose, she at least have to either drive or take a public transport, and the speed will be faster than walking speed. Yeah, so I use that information that sent back through to my system in the cloud that tag the photo. This is actually not really a legit entry, yeah, because we detected that her movement speed is actually less than, less than the car or train, yeah. So yeah, so that's not hard at all, yeah. And as an added bonus with that features, now I can actually see that if she actually speeding on the highway. Not saying that she's oftenly do this, but yeah. Well, this is something I can do if I want to now. Yeah. Anyway, so without further ado, I'm going to show you what the mobile apps looks like. Yeah, this is the recorded video of how the app actually works. Yeah, So I'm going to be silent for a moment, let you enjoy the video in the next 30 seconds. Okay, so as a clarification, if you see me there, it doesn't mean that I actually need these tools as well. Just very handy for me to be able to debug it without asking her to pause here and there, right? Because then I can just do it myself and I look at the result and do all kinds of debugging. Yeah? So yeah. So for the takeout, yeah, the deploying an AI on the edge, yeah, is actually very easy, especially if you use an AWS DeepLens ecosystem. Yeah, the whole stack is ready for you to use, and you use it yourself. If you do not need to build your own model, the built-in model is there for you. If you need to actually build a custom model, you can just branch off quickly to Sagemaker and build it, and then automatically import it into the DeepLens. So the whole technology stack in AWS is actually supporting you for the AI on the edge deployment. Yeah. And the second point I like to raise as well is you can actually expedite your AI development using Amazon SageMaker. Like you see, I do not really write any single piece of code in building my object detection, custom object detection using SageMaker, right? So this is how fast it is now to actually build an AI model now. In comparison, like if I rewind back 5 years ago, when we built Cyclops, yeah, we rely on open source code framework using TensorFlow. Yeah, that takes at least like 1 or 2 months, yeah, to get this thing up and running. Yeah? So that's the comparison now, and you can imagine in 3-4 years from today how much easier it would be. Yeah, so it's a good message for you, all of you who's scared of jumping into AI. Don't be, give it a go. It's getting easier by day. Yeah. So thank you, yeah, for listening and coming today. And I think the next section will be Q&A. And before that, like I mentioned earlier, you can follow me in LinkedIn. That's my LinkedIn link, and also the Medium blog if you want to know all other projects that I built, including the closed identification system for this particular technology product. Yeah? So yeah, so thanks a lot. So feel free to ask questions. So now I can pull it back to the moderator, Katika.
Hello. Yep. So we have few questions. Ben asks, say, 5 years is a long time in AI. So can you compare how it feels now versus five years ago?
That's a good question. Yeah, just like I mentioned in the last few slides, 5 years ago, when we have a problem to solve using AI, the first thing we do is we look for research paper. Yeah, we look for the problem that actually they're solving. Is there actually similar complexity to the problem that we want to solve? If yes, then we have a bit of confidence that okay, that it means that particular approach actually most likely will work. Yeah, and then we look at, is there a GitHub? Yeah, and what framework they use. If there's a GitHub, that's perfect. Otherwise, we have to replicate it, and the replicating somebody's research is not fun. Yeah, it can take months. Yeah. So if there's a GitHub, yeah, it's a lot easier, but it's not easy. You have to download the GitHub code and then try to get it running. Maybe you got some missing library dependency here and there, and maybe like there's backward compatibility that was created using a very, very old Python code, Python language, very old framework that's no longer supported. So all of this issue, and on top of that, yes, you got everything running, but now where is the model? Most of them normally don't publish the model. They only publish the model architecture. You got to train yourself. So now you have to collect the training set, train everything, get the model, and then once it's done, then finally you can use it. But that's not the end of it. You need to productionize it still, because at the end you only have a code that actually does the training, right? You have the model, but it can do a bit inference, but only for testing purpose. But this code is not really optimized for serving real-time inference, right? It has like maybe 20, 30 seconds, 1 minute initialization, right? Which is really not practical. So you have to productionize it, create a REST API, deploy it in the cloud. Now you have to worry about the auto scaling. if the traffic going up and down hitting your inference API. For example, like our Cyclops, we go hit like a 500,000 mystic. It's half a million images a day. Yeah, you can if you imagine that we have to be able to scale up and down our instances in the cluster. So that's not an easy task as well. So all of that is a lot of effort. But now today, yeah, going back to the point of the question, the first point for me to look at is there any readily high level tools available for us to use? For example, like Amazon Sagemaker. We want to build another image classification problem model. It's already there. Object detection already there. So we give that a go first. Accuracy is as good as what is expected. Yeah, we do not need any further customization. That's good enough. That's it. So and that's the end of the development lifecycle, because the SageMaker already built you the model, built you the inference API, handle the auto scaling up and down for you automatically, right? So if that is not really good enough, yeah, you want further customization, yeah, then yes, you have to jump in further, building it yourself. But again, if you go to the building yourself approach, it's not as hard as many years ago, because there are many alternatives now, and many people actually uploading the model now. Yeah, you do not need to retrain the whole system yourself. Yeah, like for image classification, you got Inception version 3, version 4, you got ResNet. Yeah, so many different type of model you can download now. Yeah, and especially very good framework called Keras, yeah, which simplify the deep learning development. You do not need to use TensorFlow anymore for majority of the time. It's super easy to use. If you haven't heard of it, have a look at it. It's called Keras, Keras. You can build an image classification within just 5 lines of code. Yeah, it's super easy. Yeah. So yeah, so that's really, hopefully it's answered the question. Yeah.
Yep. So the next one is does SageMaker have its own library like OpenCV, or it has to import other libraries?
No, SageMaker does not have OpenCV, so you have to import your own OpenCV. So SageMaker is very it's very geared towards like a machine learning. Yeah. So OpenCV is totally separate library, but it's not hard to actually install OpenCV yourself, right? Just pip install. I've forgotten the actual name of the library, but it's just one line of code to install OpenCV. Yeah.
Yep. So the next one, can you note the timestamps between images? And if you capture your wife twice within few seconds gap, it means she just went out to throw trash when you don't have to add the training data.
So what I actually did not really mention it in a talk, but I do not really send every single photo of her face and body. But I actually, yes, like you said, I actually have like a threshold timing. So if I already send a photo, I will not send again in the next like a 1 or 2 minutes. Yeah. So I send only 10 photos, and then each photo there is a time delay as well. For every 2 seconds, I can take another photo. But then if I already send 10, I will not send another photo until another 3-4 minutes. Yeah, just to save the bandwidth. Yeah, yeah.
And also something along the same lines. Any particular reason to go with accelerometer instead of checking if a mobile phone is connected to home Wi-Fi or not?
Oh, I see what you mean. Yeah, that's actually a good idea if you look at the Wi-Fi source. Yeah, but yeah. If it is throwing rubbish, definitely it will be within the Wi-Fi range. Yeah, but if she's in the backyard, our backyard, there's no Wi-Fi range there. Yeah, so yeah, depending on your household actually. Yeah, depending how far your Wi-Fi actually reach. Yeah. But that's a good idea. Yeah.
Yeah. So another question in the similar vein: can you substitute the cell phone camera for the image detection? So
substitute the phone camera with the
for the image collection. So I think that is rather than using a DeepLens, can you use a phone camera?
And you can, yeah, of course you can. But the problem is now you have to build the whole technology stack yourself, yeah. Because the beauty with the DeepLens is you can deploy your object detection in the hardware. Yeah, if you do it on the phone, then you have to actually build your own. I don't know if you're using iPhone, if you're using Core ML to build your own object detection, right? You have to actually do more work, and then the problem is it's also very expensive in terms of running costs, right? You do not want your smartphone sitting on the cabinet, running the whole day, taking photo and doing all this extra work, right? So it's more expensive solution, I would reckon. Yeah.
And also, can you use all the same technology but with other edge AI cameras?
Same technology with other AI camera? Yeah, of course you can. Yeah. So I also play around with other IoT device, if you're familiar with Jetson, yeah, so you can use Jetson Nano Sapphire from NVIDIA, yeah, they can do the same as well. But you need to spend more work on with them because they are a bit more low level than DeepLens. DeepLens is geared towards like very easy to use, easy to deploy, yeah. But of course, if you want more complicated, if you have a more complicated problem, you want to do more customization, Jetson is probably better because you can do a lot more there. Yeah, but then you have to ask yourself: do you need it? Do you need that complication? If you do not need it, then easy of use actually a lot better because then actually you can deploy the project quicker, right? Build and deploy quicker. So I normally use this method to actually try to decide which one to use. Yeah.
Yep. So then another one around data sets. So how about using limited, labeled or unlabeled data in general, apart from using public data sets? What's the current state in using unsupervised learning method to do data labeling?
Using unsupervised method to do data labeling. Well, yep. You can, yeah, but I don't think it will be. It is accurate enough at the moment. Yeah. So I can imagine you can always use the. You can use the image clustering technique, yeah, because you already know that here is the photo of a face, right? And you can actually then, I don't know, maybe you tile the image into a small section and you pass it into image similarity search and then to see whether this image is similar to this face, yeah. Then if it is, then you label it as a face, yeah. But I do not see there is a point because, like you see yourself, the open source the data set already available for the body. For the face, I can get 99% accurate in using Amazon recognition to label it. If you do it through the unsupervised way, definitely you will have a lot less accuracy than this. Yeah. So yeah. So the question is just definitely can, but I don't think you will achieve higher accuracy in getting the good quality data sets. Yeah.
Yep. So that's good. And there's a bunch of questions around what qualifications, what podcast you should be watching at. If someone is interested in becoming an AI developer, if someone has interest in AI, what type of resources you have out in the wild. So there's a bunch of questions, so I'm just trying to cover all of them. Yeah.
Sure. This is a very popular question, and that I always like to answer. So you have to define yourself. If you want to jump into AI, do you want to be an AI researcher or do you want to be an AI practitioner? Yeah, there are these two different directions. Yeah, there is also a direction in between. Yeah, which is just interpolation between these two. Yeah, being an AI researcher means you really want to know the mathematics behind all of this model, AI model, right? And you can actually design your own model. You can spend another 2 years researching for totally new advanced object detection. That's the AI researcher, yeah, and that's only maybe beneficial if you work for a company like they're actually building TensorFlow. You work for like a research organization, things like that. That's actually the direction you want to go to, yeah. The second direction, AI practitioner. What you want to do is you want to use the available tools to be able to understand here is the problem that I have I want to solve, and I can just use these tools or frameworks to build a solution to solve it. I do not need to know exactly inside how this model mathematically works. I don't need to know. Yeah? As long as I know how to use it, yeah, to solve problem, I understand the concept, I understand how to use it well. That's what AI practitioner is. So I recommend you if you want to try, you want to jump in first time, even though you want to eventually want to be a researcher, jump as a practitioner first. Understand the tools, yeah? Know how to use it first. And then once you're familiar with it, yeah. So there are many resources you can actually use to learn to be a practitioner. You can go to AWS site. There's I think like 15 courses of machine learning training that they published just recently. Yeah. You can go to Udemy. You can go to what's it called, the Cloud Guru. Yeah. And you can go to like even website like sklearn. Yeah. sklearn is actually a machine learning, non-deep learning framework, and they have like a massive amount of documentation, tutorials, how to actually teach you how to use every single function in the frameworks. Yeah, you can go to also Keras as well. You go to learn deep learning. There is also like a massive tutorial there as well. Example, and it's actually very easy to find these days. By simple Google search, you can even find tutorial. Yeah? And follow Medium blogs of popular people who actually like to publish articles about their finding. Yeah? And if after you're good at being a practitioner, then you decide you want to jump into researcher, then spend your leftover bandwidth to actually read starting reading research paper. Oh, what's the technique behind the scene? How to actually build this tool?